Hello and welcome back to the Maths Behind Economics YouTube channel. We are still talking about exponents for economics, and in this video I'm going to show you how to raise fractions to the exponent. Again, I'm going to remind you of the rule. We're going to work through why the rule works. Again, talk about the intuition behind the rule and the formal logic of the rule. And then at the end, we're going to look at some examples. I hope you're ready to do some maths. So let us start again by reminding ourselves what the rule is like. So let us have a fraction and raise that to the nth power. Well, that's going to be the same as a to the n over b to the n. And as a side note, I'd like to remind you and make sure that you remember and understand that these two things are not the same. Again, just like with the multiplication, on the left-hand side, we have a bracket, and the bracket signals us that both a and b have to be raised to the nth exponent, while on the right-hand side, only a is raised to the nth power or nth exponent. Okay, so be careful with these slight nuances of algebra. Right, so why does this rule work? Well, as in each case, what we're going to do now, we will demonstrate how the rule works in a specific example. 2/3 have to be raised to the 5th power. So again, use the definition of the exponent. What does it mean to raise something to the 5th power? Well, that just simply means that that same thing have to be multiplied by itself 5 times. So that's just 3, 4, 5. So 2/3 multiplied by itself 5 times. Now, how do we multiply fractions? By multiplying the numerator by the numerator and the denominator by the denominator. So in this case, at the top, we're going to have 2 multiplied by itself 5 times. And at the bottom, we're going to have 3 multiplied by itself again 5 times. And then, again, we can use the definition of exponents and just rewrite 2 multiplied by itself 5 times to be 2 to the 5th, and 3 multiplied by itself 5 times, 3 to the 5th. Okay, I hope that you followed the logic and I hope that you understand what's going on in here. Let's move on and try to do the same thing, but in this case, look at letters instead of specific numbers. So the formal proof goes like this. Again, we use the definition and we're just going to multiply AB by A over B by A over B n times. Okay, use the rules of multiplication when it comes to fractions, and then we can replace the numerator as a multiplied by itself and the denominator as b multiplied by itself. And again, in both cases, in the numerator, we're going to have n number of a's multiplied by itself, and at the bottom, we're going to have, again, n number of b's multiplied by itself. And we, again, going to use what the definition of the exponents is and replace the numerator by a to the n and the denominator by b to the n, because, again, a is multiplied by itself n times is exactly what we established that it's a to the n, and b multiplied by itself n times is what b to the n actually means in mathematics. Right, I hope you like the idea. I hope you can follow the formal mathematics with the letters. And then let's go look at some examples. I'm going to make some more space again, and I'm going to make sure that the rule is up there. Oops, went a bit too far, sorry. Right, and there is the rule. And now look at the examples. Our first example is 3 over 5 to the 7th. Well, that's just going to be 3 to the 7th over 5 to the 7th. The next example, minus 2 over 7 cubed. Well, that's minus 2 cubed over 7 cubed. And if you want to go an extra step, you can replace the minus 2 cubed by minus 2 cubed. And 7 cubed stays. Again, remember, if you multiply a negative number by itself an odd number of times, you're going to end up with a negative number. But if you multiply it by an even number of times, you end up with a positive number. Look at the next example. 2 over x to the 2nd power. Now, It doesn't matter what's in the numerator or what's in the denominator. They don't have to be exact numbers. We shown in the formal proof that you can see up above here is that it works with any kind of number. Again, we don't know the value of x, we just know that it will be some sort of number. So we can just replace this as 2 squared over x squared. And if you wanted to make it slightly simpler, you can replace this as 4 over x. I usually don't like to write out the numbers with the higher powers, like something like 3/7, because that definitely need more calculator use or something like that. But with simple numbers, like 2s and 3s and lower powers, it's usually easy to sort of replace the powers by the actual numbers, but not necessary. I'm going to write on this side so I don't have to scroll up and we don't lose the general rule. So the next example is b over 5. Let's make sure that that looks like a b to the 6th. Again, I'm going to have to replace the top by b to the 6th, and then bottom becomes 5 to the 6th. Okay, 5 to the 6th might be too big of a number for replacing it, so I'm just going to leave it like that. Next example, 2x over y, and all of this together is raised to the 10th power. But the rule that we talked about today is showing me that whatever is in the numerator, which in this case is 2x, have to be raised to the 10th power, and whatever is in the denominator, which in this case is y on its own, that's also have to be raised to the 10th power. Now you have to be careful because back at the top we talked about the 2x together have to be raised to the 10th power. So this cannot be replaced. So this is not equal to 2x to the 10. Be very, very careful. Don't rush and don't make this very common mistake. So then what was in the previous video when we had got two different bases, but they all raised to the same power, that can be replaced by 2 to the 10 and x to the 10 over y to the 10. Okay, so I would leave it in this form because 2 to the 10 again is one of those big numbers that I don't really bother writing it out. Our last example is v over 3s all together raised to the 5th power. So the numerator is just v on its own, so that's going to be v to the 5th. The denominator is 3s, so I'm going to have to use the bracket to note to everybody, including myself, that everyone's in the denominator together have to be raised to the 5th power. And again, I'm going to leave the numerator as it is because there's nothing else I can do with that. But what's going down in the denominator, I've got a multiple of 3 and s, and they together raised to the 5th power. So I can replace that by 3 to the 5th and s to the 5th, right? So that was all the examples for today. I hope you learned something new, and I hope you found the examples useful, and see you in the next one.